You have a huge box of toys, and you want to teach a robot to pick up the blocks and put them away. But how do you teach the robot what a block looks like? You show it lots of pictures of blocks, right? What if I told you computers can do the same thing? They can learn from data, and it's actually pretty cool. You can show a computer lots of pictures of cats and dogs, and it can learn to recognize them. Imagine you're trying to learn how to make the perfect pizza. You watch a video of a chef making a pizza, but you don't just watch it once. You watch it many times, and each time, you try to make the pizza yourself. The more you practice, the better you get. Computers are like you, trying to learn how to make the perfect pizza, but instead of watching a video, they look at lots of data. They try to find patterns in the data, like what makes a good pizza. A train test split is like dividing your pizza making attempts into two parts, the practice attempts and the final test attempt. So, how does a computer use a train test split? Let's say you have 100 pictures of cats and dogs, and you want to teach a computer to recognize them. You split the pictures into two groups, 80 pictures for training and 20 pictures for testing. The computer looks at the 80 training pictures and tries to find patterns. It's like the computer is trying to learn the recipe for the perfect pizza. Then, the computer uses the 20 testing pictures to see how well it can recognize the patterns. It's like the computer is making the final pizza and seeing if it's delicious. The computer uses the results from the testing pictures to improve its recipe, or its pattern recognition. Let's say you have a computer program that can recognize pictures of cats and dogs. You show it 80 pictures of cats and dogs, and it tries to find patterns. Then, you show it 20 new pictures, and it tries to recognize the patterns. If it gets 18 out of 20 correct, that's like making 18 delicious pizzas out of 20 attempts. The computer can use the results to improve its pattern recognition. For example, it might realize that it's having trouble recognizing black cats, so it can practice recognizing those pictures more. You can see how the computer is getting better and better at recognizing the pictures. So, why is it important for computers to use a train test split? It's like trying to make the perfect pizza. You want to make sure your recipe is good, so you test it many times. If you just make the pizza once and serve it, you might not know if it's any good. Computers are the same way. They need to test their pattern recognition many times to make sure it's good. And that's why a train test split is so important. It helps computers learn from data and make accurate predictions. So, let's recap what we learned. You now know that computers can learn from data using a train test split. You know that the train test split is like dividing your pizza making attempts into practice and final test attempts. And you know that computers use the results from the testing attempts to improve their pattern recognition. That's like making the perfect pizza, and it's a key part of how computers learn from data. Next time, we'll learn how computers actually learn from data. It's like a special sauce that makes the perfect pizza. You'll discover how computers use something called gradient descent to improve their pattern recognition. It's a powerful tool that helps computers learn from data, and it's used in many real-world applications. Subscribe to our channel to learn more about AI and machine learning, and we'll see you in the next lesson.